Okay, so what is an ERD? Okay, so that is what we are going to discuss in this video. Uh, the entity relationship diagram. Okay, so as it is defined, it is a type of structural diagram for use in database design. Okay, so structural diagram. So first of all, it is a diagram, so therefore we could see some drawings here. Okay, then structural in a database design. So basically it is actually a diagram for the structures in our database design. It contains different symbols and connections or connectors that visualize two important information. Okay, first is the major entities, and the second is the relationship among those entities. Again, the keywords here: entities and relationships. Okay, so this is an example of a complete ERD. Although not necessarily complete, but an example of an entity relationship diagram. So we have here some entities, attributes, and relationships. But anyway, we're going to have them one by one on the next slides. Okay. So first is we're going to define what an entity is. Okay. So it is just actually the other term for a table. Okay, so we have already discussed what the tables are. We have worked with tables. So here in our ERD, those are called as entities. Okay, it is a definable thing or concept within a system, such as a person or a role. Okay, it could be a student, an object. For example, an object is an invoice, or a concept. For example, a profile for a student, or even an event. Okay, example here is we have a transaction. In ERD, the term entity is often used instead of table, but again, they are the same. Okay, so when determining entities, think of them as nouns. Okay, so the tables are nouns, and the symbol for an entity in an ERD is a rectangle. For example, this is an entity for a student. Okay, so a rectangle, then the name of the entity. Okay, so next, okay, so we have a type of entity. It is called a weak entity, or tables or entity that are dependent to other entities. Okay, an example for by the way, the symbol is double line rectangle. Example for this one is a profile. So meaning in this example that we have, a profile is dependent to a student. So meaning a profile record, a profile table could not exist without the student entity. Okay, so that is why it is called a weak entity. Okay, so next is we have the attributes. Okay, so entity is the table, then attribute is a column. Okay, so it is a property, take note, property or characteristics of the entity that holds it. Okay, and the symbol is oval or ellipse. Wrong spelling. So we have here an example. For example, for the entity student, so we have here an attribute named last name. So it is oval, then we have the last name, and this should be connected into our entity, although I'm going to show you that in a later slides. Okay, so again, entity is for the tables, then attributes is for our columns. Then we have, okay, this is now an example of entities and attributes. So we have here a single entity, so we have a student, then we have the different attributes. Okay, the home address, last name, first name, and the email address. Actually, we could still have more attributes if we are going to have the complete columns or attributes or the properties of the entity student. Okay, so we are not limited actually to 4, but we could still have some more attributes. Okay, so they are connected with a line. Okay, so next is we have the different types of attributes. So first is we have the simple attribute. So a simple attribute is an attribute that cannot be further subdivided into components. So in our given example here, the simple attribute could be a student ID and the gender, because name and home address could still be subdivided into different components, okay, in which I'm going to show you later on. Okay, so again, in this example that we have, student ID and gender are only the simple attribute, because name could be subdivided into last name, middle name, and the first name. And for the address, we could subdivide this one into street, city, region, and so on. Okay? So again, only the student ID and the gender. Okay? Then the composite attribute. Okay? So composite are combinations of two or more attributes that uniquely identify a record in a table together. So in this example that we have, the composite attribute is we have the name and address. Okay? So as you can see here, our address still subdivided into, okay, so this is in the US, so that's why we have here the state, street, and the zip code. Okay? And for the name, we have the first, the middle, and the last name. Okay? So again, these are the composite attributes. Then we have the derived attributes. These are the attributes that can be derived from the other attribute. These attributes are not present in the database physically, but they can be derived from the other attributes easily. Okay? In this example that we have, the derived attribute here is we have the age, in which age is derived from date of birth. Okay? So physically, it is not on the database. It is not actually a physical attribute of the student, but it is derived from the other attribute. An example that we have is the date of birth for the derived attribute, which is our age. Okay? It is dotted ellipse. Okay? Oval. Okay? Then we have the key attributes, refers to specific fields or columns in a table that are used to uniquely identify each record in the database. Uniquely identify, meaning those are our primary keys. Okay, these are used to enforce the integrity of the data and to ensure that each record can be easily retrieved and updated. Okay, so in the example here, we have the student ID as our key attribute, and it is underlined. Okay, so to identify a key attribute, we must have to underline that given attribute. Okay, so again, key attribute or the primary key, so we have this one here. Okay, so there's still a lot. Okay, we have the complex and so on. Okay, but I just presented you here the most commonly used attributes or types of attributes. Okay, so next is we have the relationships. Okay, so a relationship between two entities signifies that the two entities are associated with each other somehow. Okay, so meaning there exists a connection between the two entities. Okay, in our previous examples, we have the students and subjects database. Okay, so we have here a student entity and our course entity. So there exists a relationship between our two entities. Okay, and they are represented with this symbol. Okay, it is a diamond and connected with a line. So meaning student takes course. Okay, in other countries they call it program. Okay, here in the Philippines we call it course. Okay, then that is from the relationship student to courses or to course. Okay, student takes course, or the other way around, course is taken by student. Okay, so this is the relationship that exists between student and course entities. Okay, how about into our student and subject entities? Okay, so here student enrolls in subject. Okay, so during enrollment, students are going to enroll one or more subjects. Okay, or by the way, in other country they call this one here as course. Okay, program, course, but here we call it course and subject. Subject means English 101, Mathematics 1, Algebra, and so on. Course is Bachelor of Science in Information Technology, Bachelor of Science in Nursing, and so on. Okay? So, uh, then from subject to student, subject, to say, what's the verb? By the way, this is the verb. Okay, so if this is the noun, this is verb. A student enrolls in subject, and in a subject is enrolled by students. Okay, so this is how are we going to signify the relationship between uh, entities. And by the way, we are not limited to only two entities, but still, as you can see here, we have a single student entity, then it has a relationship with a course and subject. Okay, so next is we have this what we call as cardinality. Okay, so defines the possible number of occurrences in one entity which is associated with the number of occurrences in another. And as I've said, in these entities, there exists a relationship between the two. Okay, and there is actually a cardinality on their relationship. For example, one student, no, one course is taken by many students, or many students take one course. Okay, that thing one and many are actually our cardinalities. So we have here the different cardinalities. One-to-one cardinality, okay, is mostly used to split an entity into to provide information concisely and make it more understandable. For example, in a student entity, we have actually, if when you signed up with your enrollment form, there are actually a lot of columns that you need to fill up in our student entity. Okay, so to simplify the student entity, you could split, okay, this entity into multiple entities. For example, student, then education, let us say student profile, personal profile. Okay, and if ever we have a student split into two with a profile, so therefore there would exist a one-to-one cardinality, meaning one student can have one profile. Okay, example here, user and user profile. Okay, so that's one-to-one cardinality. So we have here also a one-to-many cardinality. Okay, refers to the relationship between two entities, x and y, in which an instance of x may be linked to many instances of y. Okay, an instance meaning one instance of x may be linked, or one record in one table can be linked to many records to y, but y is linked to only one instance of x. Okay, a very good example for that is we have the student and course. Okay, so many students, okay, this is many, take one or can take one course. Okay, so or one course can be taken by many students. So one record here has many instances or links to the student, but each link on the many side has only one link into our one table. Okay, so that's why we have one to many relationship. Okay, we're just going to have the symbols later on. Okay, so again, one course can be taken by many students, and many students take one course. Okay, so that's one to many cardinality. Then we have many to many cardinality. Refers to the relationship between two entities x and y, in which x may be linked to many instances of y and vice versa. So that's like many to many. Okay, for example here, this one here is actually many to many. So Okay, I'm going to have first. One student can have many subjects. Okay, so with that alone, we could say one to many. But one subject could be taken also by many students. Okay, so therefore, an instance of this entity here or a record here could have many connections to this entity and vice versa. One student here have many connections to our subject. So therefore, many to many. Okay, so many students can enroll to many subjects and vice versa. Okay, or to be strict, if we want to be stricter, so it could be there are still cardinalities later on, one or many, zero or many, and so on. Okay, but as of now, we're just going to have it as many students can enroll in many subjects. Okay, so how are you going to differentiate one to many and many to many? Because we could say one student can take many subjects. Okay, so one course can be taken by many students, or one subject can be taken by many students. But then, vice versa, one of the student here can take only one course. So that's why we have here one to many. But here, many subjects can be taken by, or one subject can be taken by many students. But then, one student can also take many subjects. Not just like on the above that we could not say one student can take only one subject, but one student can take many subjects. And one subject could be taken by many students. So that's why it is vice versa. That is why it is many to many. Okay? So these are the general types of cardinalities. So how are we going to specify the relationships or the cardinalities of entities? Take note, this one here is the relationship, and cardinalities would be here. Okay, so we have here the symbols for the cardinalities. Okay, crow's foot notation. Crow is a bird actually, so it is a visual language used in ERD to depict the relationships the relationships between entities in a database. Okay, so that is one. Okay, then we have the foot of a crow, so we have many. Then we have one and only one. To differentiate this, okay, one and only one is we have the student and the student profile. Okay, so to be strict, the relationship would be one and only one. Okay, 0 or 1. So it is possible that the relationship could be 0 or 1. So for example, okay, we still have no, we could not have it here, but 0 or many, maybe one student, for example, I don't know, student could belong to a course, although it is impossible, but the student doesn't have a subject yet, so that could be 0 or many. But again, it is not applicable here. We're going to have an example later on for 0 or many. Okay, so here, maybe 0 or many or 0 or 1. For example, in our previous example, database example before, for example, in the database where we tried to determine the phones used by employees, that could be 0 or many, because an employee can have 0 or many phones. Okay, so that's an example of this one. Or 0 or 1. Okay, try to find anything that it is possible, optional. So this is actually optional. It could be 0 or he has 1. Okay, so many wife, but anyway, we could have many wives, 0 or many wives. Okay, this is 0 or 1 wife, maybe, or 0 or 1 husband. Okay, Then one or many. Okay, so this one here is strictly many, but it is possible that in a relationship the cardinality is one or many. Okay, so or zero or many. For example, boyfriend or girlfriend, so it could be zero or many. Seldom, zero or one girlfriend will never happen. Anyway, seldom happens, but always we have this one or many. Okay, so we are going to apply now these cardinalities into our example. Okay, so we have here now our cardinality example: student to subject. Okay, student enrolls in subject. Okay, by the way, since these are noun, it is suggested that we are going to use singular. Okay, so it is better to use here singular, even though we're having here a many cardinality, but still we are going to write the name of the entity as in singular form. Okay, so this is one or many students, okay, enroll in one or many subjects, because when you are going to enroll into a school, at least you have one subject. So we could not use here zero or many, but one or many. Okay. By the way, okay, a subject. By the way, we should use this one here as a zero. Okay, an optional, because it is possible that a subject is enrolled by zero or many students. Okay? But in a normal situation, this should always be at least one enrolled student for every subject. Okay? So these are the cardinalities. So meaning many students can enroll in many subjects. Okay? Then many students take one course. Okay? So it could not be zero or one. It is because all students must belong to a course so that he could take those subjects. Okay? And one course could be taken by many students. Okay? So this now, the cardinality. How are we going to illustrate the cardinalities between entities? So an entity, relationship, and the cardinality. And the complete ERD is we have this one here. Okay, so we have the attributes. Okay, we have the entity, the relationship, and the cardinalities. Okay. By the way, you could still add some more attributes, but anyway, I just used these attributes so that it would be cleaner as I'm going to present them to you now. Okay. So this is what we call as key. Our primary key, it is underlined and so on. Okay. And by the way, if ever that we are going to have the complete ERD, it would be more cluttered. Maybe we are going to have here the semester, the school year, teachers, and so on. Okay, so it's up to you then. How are you going to arrange your entities? Okay, so next example is we're going to have, just like with our previous videos, we're going to have our the library management system ERD. Okay, so what are the entities? Okay, based on what we have discussed before, is we have the publisher, the author, and the center of it, so we have the book and the borrower. Okay, so we have not included here other things such as, for example, the reservation, what else? The librarian, the staff, and so on. Okay, we're just going to have here a simplified ERD for a library management system. So we have only 4 entities that we have identified. Okay, then we have the relationships and cardinalities among our entities. Okay, publisher publishes books. Okay, one. By the way, you could just use here one. I didn't find a one, or I was just actually too lazy to find the one symbol. So we could have here one. Or but anyway, book could be published by one and only one publisher. So far, that's what I know. Okay, but if ever it is possible that a book could be published by one or more, so we could have one or many. Okay, but as of now, is we're going to have our book is published, or many one or many books are published by one and only one publisher. Okay, then the author. Author writes books. Okay, or one or many books writes. Oh no, one or many authors write one or many books, because it is true that a book could be written by many authors. Okay, but it's also possible that there is only one author who write a single book. Okay, but then possible that one author could write many books, or one book could be written by one or many authors. Okay, then for the borrower, okay, so again, still we have one or many relationship. Why? Because a borrower can borrow one or many books, or one or many books could be borrowed by one or many borrowers. Okay, so we have one to many, and all of them are many to many. Okay, so that's the cardinalities into our library management system, ERD. And for the complete ERDs, we have this one here. We have now included what's this? The attributes for each of the entities. Okay, so again, the complete ERDs, we have the attributes, the entity, the relationship, and the cardinalities among on the relationship among entities. Okay. By the way, I am using here draw.io editor. Okay, so as you can see here, you could access freely this one here on app.diagrams.net, or you could download the desktop version on this URL. Okay, so as you can see, the ones I have shown you in the previous slides, actually I drawn them here into our in app.diagrams.net. Okay, so as you could observe, I have first introduced to you the tables. Okay, basically the actual tables. Okay, then how we dealt with those tables, and it is only now that I am introducing to you the ERD. Okay, so we have started with the details, and we are having now the more general way in designing our database, in which in the next video I'm going to introduce to you how are we going to convert this ERD into logical design. By the way, ERD is what we call as the conceptual design. Okay, and later on I'm going to discuss to you how to convert or how to translate this one here into logical design. So that will be on the next video. So that's all for today, and I'll see you on the next one.